Well, hello everyone. Um, let's get moving. We're going to be looking at chapter 8.3 in particular. We're going to look at moments and centres of mass, and the three situations we're going to look at are moments, centre of mass of 1D situations, two-dimensional situations, and then centres of mass when you're talking about the area under a curve and what that centre of mass in that area under the curve would end up being. So in each one of these situations, I'll try at least to describe the method that we would use to get them. Centres of mass are very often useful in engineering, especially structural engineering, people who build bridges and so on. Because what it allows you to do is to take quite complicated structures and simplify them down into a single position. And that position is the centre of mass. And you want the centre of mass to be in particular places depending on the structure of the object that you're interested in. So that's essentially what it is. I know I'm a bit slow today, but got to forgive me, I'm not 100% yet. So let's look at our first situation. Moments, centre of mass in a 1D world. So imagine you've got it could be a girder or a piece of wood, something straight, and it's got on it, in this particular case, on 4 different locations, it's got a mass, 4 masses of different weights. And because when x is -4, there's a mass of 1, there's a second mass, here is the third, and that's the fourth. Well, the center of a mass called x bar is roughly here, right? If you could physically get this object and you put your finger there, it would actually balance, right? The left and right hand side would be equal. Now, to get the center of mass called x bar, it's a relatively simple equation. You take what's called the moments, capital M, and divide it by the mass, total mass, little m. And the moment, capital M, is described by essentially multiplying mass by position, in this case 4 times. And that ends up being -1. And the total mass would be 5 add 4 add 10 add 1. And that gets you 20. And you take the moment, and you take this guy, and you put them together, you get -1/20th. And so that's essentially where the centre of mass of that question would lie. Now let's look at another situation, still in the 1D world. It's here. This time we have 3 masses located at 3 points. We're going to calculate the moment by multiplying the mass and its position, its x coordinate. That comes to 10. The total mass, what you get when you add them up, and in this case it's 16. And the centre of mass is the moment, that's this top piece, divided by the total mass, which is that bottom piece. 10 out of 16 becomes 5/8. And one more example of that. This one here. Again, we're back to having 4. And we're going to get the centre of mass. The moment, capital M, is 5 times -4, 4 times -1, 10 times 2, and 1 times 3. And that ends up being -1. And the total mass is 20, so you get -1/20th in this case. And we are essentially finished. So if you want to find the centers of mass on a one-dimensional object, that's what you would do. The center of mass questions that involve one-dimensional objects, I'm just scanning through right now, are questions 1 and 2. So let's up the dimensions and look at how do you get the moments in center of mass of a two-dimensional object. Well, imagine you've got in the coordinate system 3 points with a mass of m1 at this point, a mass of m3 at this point, a mass of m2 at this point. And we wanted to know the center of mass of this object. And consistent with the first one, we use the notation x bar to be the x coordinate of the center of mass and y bar to be the center of mass, y coordinate of the center of mass. Now, x bar is the moment over the y's of little m, and y bar is the moment to little x, and mx is what you get when you do this, and my is what you get when you do this. So when you actually look at the equation in all its glory, this guy will be m1 x1 plus m2 x2 plus m3 x3 over m1 plus m2 plus m3. That intuitively sounds right. You imagine dropping all these things down to the x-axis. Now, if you want to get y bar, you're talking about m1 y1 plus m2 y2 plus m3 y3, also over the total mass. You know that you could extend this to 3 or more dimensions, but we're only going to do 1 and 2. So let's do an example with some numbers. Suppose I have a point here, and the mass, call it m1, is 10, and the coordinates at the point are 3, 2. I have another one down here, I'll call it m2. Its mass is 5, its coordinates are 1, -2, and we have a point here, which I'll call m3, and its mass is 5, and its coordinates are -3, 0. And we would like to know the center of mass of this system. So what we would do is find the x bar value, which is m1 x1, m2 x2, m3 x3, all over m1, m2, m3. And this is going to be 10 times the x coordinate, which is 3, plus 5 times the x coordinate, which is 1, plus 5 times the x coordinate, which is -3. And this gets me 30, add 5, take away 15, and I get 20. And on the bottom, we get 10 add 1 add 5. And we get an x bar 5 quarters. To get the y bar, very similar calculation, but we use the y coordinates. And this time it's going to be 10 times 2 plus 5 times -2. plus 5 times 0. And it's going to be over 10, 1 and 5. 10. Oh dear. 10, 5, and 5. So the bottom is actually going to be 20. And the top is going to be 10. So that is a half. Let me go back and fix this one. That one there is good. Let's see. 10 times 3 is good. 5 times 1 is good. 5 times -3 is good. So it's the bottom. Mass 1 is 10. Check. Mass 2 is 5. Which makes this guy 20. Which makes this 1. So if we imagine where the point 1, a half is, because the centre of mass is 1, a half, we essentially get a point that looks something like this. There's 1, probably about there. And that is essentially how you find the centre of mass in a two-dimensional situation. Let's do another one where instead of being given a picture, you're told the masses and you're told the coordinates of each of those masses. Now, X bar then, the moment over the Y's, M. That guy is M1, X1, M2, X2, M3, X3, over M1, M2, 3. So 1 times 1 plus 3 times -1 plus 2 times 2 over 1 plus 3 plus 2. So I get 1, take away 3, add 4 over 6, which becomes 2 over 6, which gives me an X bar of 1/3. To get the Y bar, it's simply just going to be M1, Y1, M2, Y2, M3, Y3 over the total mass. And M1 is 1 times 3 plus 3 times 1 plus 2 times 1 all over 1, add 3, add 2. And that gets me 3, add 3, add 2 over 6, which is 8 over 6, which gives me 4/3. So the centre of mass has coordinates X bar, Y bar, which is 1/3, 4/3.